Welcome again, everyone, to our 25th Annual Capital Conference virtual edition. We're glad that you're here. This is NumberSense Q&A session, part 2. Our presenter is Larry White, our State Contest Director for NumberSense. If you have questions as we go, you can enter those in the chat, or you can unmute and ask questions. I think most of you were in the first, the part 1 sessions. We'll kind of handle it the same way, but I will turn it over to Larry.
Well, I'm back, and some of you are too. We didn't chase everybody off earlier. Welcome to the second part of our NumberSense Zoom session, virtual. As David said, hopefully this will be our last, and I'll get to see all your smiling faces in face-to-face in the future. But let's go ahead and get started. As we did in the first session, if you have a question, just unmute your button there and ask the question, or if you don't feel like doing that, you can post something in the chat question. I did want to say something earlier. Yes, I see your question there, Lexi. I'll address that here in just a second. I did want to make sure you all understand, when you look at my presentation, you'll see my email address on that presentation. I encourage you to contact me if you have questions, not only about how to do a problem, but maybe it's how to help your kids improve their speed or to get them motivated. I will be more than happy to help you in any way I possibly can to help you help your kids, because this mental math thing is a very valuable tool for kids to have, not just in competition for UIL, but for their future, to be able to think on one's feet. So feel free to use that email and contact me. If you ask me a question that I can't answer for you because it's a new problem or something, we'll address it later. But most of the time I can help you, or at least give you lots of good hints on where to get to places. Do not let your students email me. I can't take emails from students. Obviously, that would be several thousand a day, and I don't believe my server would handle it. But please, coaches, feel free, especially the younger coaches, the new coaches, feel free to email me and pick my brain. I will do everything I can to help you have a successful program in the future. Now, let me go down there to that first chat question. And Lexi wants to know, to start, you're a beginning teacher with a mixed group of kids as far as skill level goes, some experienced and some newbies. Well, first off, you need to do is decide at what level they're at. But when I'm working with newbies, I start very basic. I make sure they understand the things they have to know. Let me go show you a little bit of what I'm talking about. And where's it at? Where is it at? Where is it at? Well, I can't find what I'm looking for. There it is. Yeah, every student that does NumberSense needs to know these things to begin with, right off the bat. You need to make sure the kids can repeat their first 35 squares backwards and forwards. They need to know what 21 squared is 441 and so on. They need to know those immediately. Then they need to know their first 15 cubes, 1 through 15. They need to know their first 10 square roots to 3 decimal places. Square root of 2 is 1.414. They need to know their onesies. That's 1/2, 1/3, 1/4, all the way up to 1/12, and include 1/16. They need to know the decimal, fraction, and percent equivalencies for those things, because the test is just covered in that area.
Larry,
Yes,
are you trying to, you got something that you're showing? Because it just says that you started screen sharing, but it's blank.
I just now saw it. It just, let me try it again. Because it just did, yeah. No, somehow it's got it paused. I don't know why it's pausing. Ah, it's not resuming either. Well, let me try something else and see if I can get it back. Does that, can you see that now? Yeah, I don't know what was going on. Okay.
There it is.
Yeah, okay. All right, sorry about that. So anyways, and this is in my presentation that you can download and watch as well. But these are the things that the students need to know. Roman numerals there's one problem, it's not a big deal. But the other things they need to know are remainder rules all the way from 2 through 11 and estimation strategies. These are things that all your students should know regardless of what level they're at to begin with. Then, now go back over here. Then what you want to do is you want to start with the very basics. And if it were me, if I had some brand new kids that had never been in NumberSense, I'd get a hold of some elementary or middle school tests and start there because the problems are not as intense and there's more simplified problems. They can see the problems easier as they're going along. So you have to start in the beginning to sort of lure them in, to get them excited about coming into the play. And then if you have some more advanced kids, let them take over the program and be there to watch them and help them. Let them draw the newbies in to the program because they're the ones that can share them with ideas. And somehow the newbies tend to listen to the oldies better than they do to us old people. So yeah, it's getting started is not very simple, but like I say, I would get some elementary tests and some middle school tests, and I'd start off with the first column 1 through 20. I suggest instead of using notebooks, they get 3x5 or 5x7 note cards and start putting down problems with the shortcuts on each card so they can carry that around with them. If it's a notebook, they tend to they don't want to leaf through all those pages looking for something, but those little 3x5 cards or 5x7 cards they can flip through. I was looking around to see if I had mine around, but I don't know where it's at the moment. But anyways, that's a nice little strategy. Make those cards. And make NumberSense visible even through your regular classrooms. Put something up on your bulletin board, put up a shortcut, on the bulletin board, a basic shortcut, put it on your classroom chalkboard or overhead so the kids can see math as visible. So that's a pretty nice thing to do as well. I see the other questions there, so hang loose a second and I'll come back to you. I wanted to, I think this is the one yet. This is the 2020 SAC test, which you can download now because it's on my website page, the UIL website page. This is where you can download, and these are what the problems sort of look like. But these first 20 on elementary and junior high are even more simpler than these. And that's where I would start with your young people and your experienced people. They can use the brushing up and the touch up. It's good practice for them to go through quickly and do a lot of problems. But you can see there's that 5/8. That's one of those equivalencies. That's an automatic answer because they're supposed to know their onesies, and 5/8 is just 5 times 1/8. So there's a square, so they have to know their squares. There's a percentage, so they have to know how to get that back. There's some more square problems. So you can see some of these problems like just require onesies and equivalencies as they're going along, and they're squares and they're cubes. But this is what it sort of looks like. So to answer that question, I would say start out very basic, even for your, get your more experienced ones to help your younger ones learn, because that helps them retain and know things even better. So that's how I would always begin each year. The real key to NumberSense is to get their attention, get them excited about wanting to do things quickly in their head, and then you can move forward and do other things. Okay. Let's see what this, see what Mr. Walker asked here. Yes, Ken, I looked at the scores and I contributed part of it to the chaos of the COVID and not being able to be with the kids as much as we would like to. But at the same time, I went through and I handpicked problems that I think I put too early in the test. And I think it caused the kids to slow down considerably. By the time they got to state, you know, we had kids that were finishing the test. But yes, I noticed that the tests were slower and the scores were lower. And I think that's a combination of not being able to practice enough, work with your kids enough, and me as a test writer being careful to not let that first 40 be overwhelming where they can't get after it. So I'm working real hard on getting that first 40 at a quicker pace and less difficult. Same ideas, same concepts, but less difficulty. So yeah, it's I agree. They were definitely, the scores were definitely lower until we got into district, regional, state, where the kids were practicing. The kids didn't get to go to a lot of practice meets like they did in the past, so they couldn't score as much. So yeah, it definitely was an issue, but I'm working on that, and I hope the scores will get up this year by me looking at them a little. I'll have a little more time to look at the NumberSense test since I'm not doing the math anymore, so I can dedicate a little more time in there. Okay, Heather, how many practice meets are recommended? That's totally up to you and your students, and more importantly, to your school, because the school foots the bill. And a lot of times they don't want to send kids off the deal. When I was coaching and I had a real active math team, we would go to 10, 12 practice meets a year. But most schools can't do that. But yes, you need to go to some practice meets. Now, I'll tell you up front, I write TMSCA tests and UIL tests. I write test number 6 for TMSCA, number 13 for TMSCA, and TMSCA state. And this year I'll write a district warm-up test. And I also write the A test and the B test for UIL. Those 5 tests and the SAC test are the tests that I use for writing district, regional, and state. So if you're going to go to any practice meets, you want to be sure and go to the one that is offering a TMSCA number 6, number 13, and the TMSCA state. You want to go to those 3 to be able to get a hold of those tests. And then any test, any invitational test that does the A test, which is in January, and the B test for UIL, which is in February. You want to be sure and go to meets where you can get a hold of those tests. Now, if you can't go to meets, you can actually still purchase those from TMSCA UIL after their deadlines have reached. So yeah, it depends on how much your kids want to go, and how much your school will allow them to go. There's some of us that used to start in September and start going to practice meets and go to a bunch of them if the kids in the school is willing. The more practice Saturdays they get, it's better. However, I've had some schools make it to state that don't go to practice meets. They just practice a lot at home. And there are other methods if you can't go. Let me share the screen again here. There are some other methods if you can't go to a actual practice meet. You can yeah, that's not what I was looking for. Hang loose, I'm scrolling through. This is all in the thing you can download. Well, I was looking for one and oh, okay. Chuck Thompson with the virtual challenge meet, he has virtual meets all throughout the year. And so if your kids can't go to actually physically go, you can get a hold of Chuck Thompson, and he does the virtual challenge meets throughout the year that you can actually take tests, take the test through a virtual challenge meet. There's also, and this is a new slide in my presentation, there's also this Education Academy. This was done by 2 young men that were NumberSense state champions several years ago that went off to college and got their big degrees and came back, and they developed this Education Academy, and they do math, regular math class tutoring. They also do UIL tutoring, but they're also doing some practice meets where you actually compete online. You see the test online, they all take it at the same time. They did this TMSCA state meet this last year, and it really turned out nice. So that's another way, if you can't make it to any practice meets, that's another way to get some practice in. And then a couple of quick things since I'm here. This Texas Math Mundo, it's for those of you that know, Saul can too. If you haven't been to this, you need to go there. He's been wanting to make UIL more transparent, and he's been interviewing students and coaches. He interviewed me. He interviewed a bunch of the state champions and questioned them how they got to where they are. Really, really nice insight. He's got a whole bunch of YouTube videos that are really nice to see. So if you get a chance, go there. It's pretty nice to have. And then, of course, we couldn't have the math camp at Texas Tech this year because of the COVID. We couldn't do it last year either. But we are scheduling the math camp again at Texas Tech next summer on July 11th to the 19th. You can go to that webpage or contact Jack Martin, and he'll give you more up-to-date information on that. The math camp is really quite neat. It's really not just a math camp. It's science and math and computer. Some part of the computer stuff is going on now, and NumberSense and calculator. It's all there, but it's a math science camp. And some of the, like I'll be there, and Cliff McCurdy will be there, and Andy Zapata and Wenzen Zhang, some of the good math folks that will be there helping. So it's a great camp to go to if you can get your kids to go there. So get a hold of Jack before so that you can get into his camp next year. It's really pretty and good. Okay, see what else is on the, Yeah, there, okay. Okay, let's go back and see. Okay. Am I going to share the presentation? Yes, you can get it. David put a link there where you can go see that YouTube video where I did this presentation. And if you can't find anything through all this stuff, folks, just shoot me an email. I'll guide you there. I won't lead you astray. So I will make sure you get all this information for you to have. What is the computer software I have on the download? Now, are you talking about in my presentation? I would assume. I assume you're talking about this computer software, whoever asked that question. I have a program that I developed many years ago that you can purchase, and it's great for beginning steps. And best thing I can tell you there, because I really don't like to talk about this much when we got other things we talk about. If you will email me, I will send you all the information. I'll even send you a demo and tell you all about how this thing works. It's pretty good, especially for beginners. And it's good practice for the old timers as well. So you may want to look at that. Okay, so let's move back where we are. Okay, did we get rid of all our chat questions?
Hey, Larry.
Yes.
Hey, just to let everybody know, I don't know how many of you might know, but Jack Barton up at Texas Tech, they hold what they call the Math Bowl in September, October timeframe. It's a really fun experience for the kids. They compete as a team, sort of like the old College Bowl type thing. And they have questions on math, number sense, and calculators. So it's really something that they might want to look into just for general fun to get the kids interested. My kids, we did it. They just fell in love with it.
Yeah, it is really a lot of fun. It's just like the Math Bowl on TV, you know, where they get together. Yeah, they had a great time doing this before the COVID hit, and they're anxious to get it started back. So yeah, Jack Barton up in Tech is doing a lot of stuff for UIL. They run several practice meets through the year besides the camp and the Math Bowl. So yeah, get on their Texas Tech webpage and see what all he's got offering. And if nothing else, get a hold of him. He's got some good stuff going on. Okay, good job, Jimmy. Mine was. Anybody else got a question in particular? And I'm going to take us over here for a time being while you're thinking about questions. As again, this is the, move our pictures out of the way. You'd rather see the problem than to see our picture. Maybe I can get it smaller. Yeah, that'll work. Can you still see that, I guess? Yeah, let me do this. Okay, this is the SAC test from last year, and there'll be a SAC test this year called the 2021 SAC test. And it will contain a bunch of the new problems for this next year. And there's really not a lot of new problems, but there's new renditions that come about. But I wanted to mention it since, you know, okay, if you come up with a question, stop me and let's answer your question. I'd rather you answer your questions than me pick problems. But since we don't have any more questions at the moment, I wanted to look at some of these. I'm looking at number 1 right up here. And I'm always amazed when I ask coaches how their kids work these problems. So many of them add them by place value They add the 9 and the 1, then the 3 and the 5, and they can do that, but it becomes cumbersome and long. If you would teach your kids to look in blocks, if you look at that thing in sets of 2, that's a 78 and a 6 is 84. That's a 39 and a 51. That's 90. It's 74, 90, and you're gone. The problems are what we call compatible type problems. So look for compatibility. Instead of doing 9 and 1 is 10, carry your 1, 5 and 3 is 8, add one. Look at 39 and 51. It's 90. It's a good way to get your kids to look at addition and subtraction of whole numbers by looking at compatibility. It makes things a little better. There's the 5/8. And if you knew your 1/8 decimal, which is 0.125, then you know 5/8 is 5 times 0.125. That's that knowing your onesies, it's become important. So that's on the test. 19 squared is one of the 35 squares, and you're supposed to know it automatic. It shouldn't take, you should be able to put the answer down rather quickly. Here's 15 squared and 16 squared. And I brought this up to you for a reason, because I wanted you to see number 14 and I wanted you to see number 19. Both of them are the exact same problems. They're squares. 15 squared, 16 squared, one is a sum and one's a difference. Now, being able to do NumberSense means you have to be able to recognize there's a shortcut. I don't know of any sums of squares in mathematics. So that particular problem, number 14, you would have to actually know your 15 squared and 16 squared, which you're supposed to know, 225 and 196, I'm sorry, 296, and add them together to get the 441. So you have to know your squares. Now, if I go over here to number 19, now we've found there's something interesting here. In algebra, we teach a thing called difference of squares, a plus b times a minus b. If you add 16 and 15, get 31 and subtract it, that's just 31 times 1. And the answer is 31. If you use your algebra skills to develop strategies, you can make NumberSense go fast. You could have taken 16 squared and you could have taken 15 squared and subtracted them. But if you know that a squared minus b squared is a plus b times a minus b, that's 31 times 1 and the answer is gone. That's a really, really nice use of algebra to make a creative strategy. So you'll see problems like that a lot. Then 22 is an interesting problem. And I put it as a very simple, basic problem because 3 times 37 is 111. 37 has magical powers because of that 111. So anytime you see a problem, a test problem that's got that 37 in the denominator, it's got something happening with the number 111. So you want to look at that problem and tell your kids, we need to play with 37. If that was 5 37s, it would be 555. I'm sorry, it would be 15 because the 37 and the 111 gives you that 3 every time. And so if there's 5 37s, the answer is 15. Knowing those little things like that is crucial. Like say, stop me if you have a question. I can even demonstrate some of these if need be. 1795 times 5 plus 25. I started using this a couple of years ago. And the uniqueness to this problem is that the answer is the 1795 is 5 away from 1800. henceforth it's times 5, henceforth it's plus 25. And as it turns out, that is just nothing more than 5 times 1800. It's a bunch of those problems I like to do, and it all based off the difference between the 1795, or it could be 1693, which is 7 away from 1700, and then plus 49, and that will work every time. Let me check this question, then I'll show you that again. Oh, you're welcome. Okay, let me go play with that. Where I can do it with my iPad. Come on, you can do it. Yeah, that was good too. Seems like my iPad doesn't want to share. It seems to be struggling for some reason. Hang loose and I'll see if I can get it going. I may have lost a there it is. When you live out in the country, sometimes the internet's not the booming thing. Okay, let's go back to that problem. 1795 times 5 plus 25. You can create problems like this all day long. And I suggest you get the kids to where they, when you find these problems or create their own, to actually work it out with a calculator. And when they get that final answer, they end up getting this. And they'll go, wow, that's pretty neat. Well, what happens if that was 1793 times 7 plus 49? Well, let's see. Mark over. And if you notice that right there is nothing more than 18 times 7. And that problem works out every time. It's a great proof, by the way. And it doesn't have to be just in the 17s. It can be 1698 times 2 plus 4. And that'll just be 2 times 17, 3,400. That little neat problem works out all the time. It's really a classic little thing. It's a great math proof to sit down and prove that thing. So getting your kids to see and identify problems getting them to recognize those problems is really crucial. Not every problem has a shortcut. You have to be able to recognize where those shortcuts are. Let me stop that a second. I saw a message come up.
Yeah.
Can I Yeah. Can I
Yeah.
explain what? Can I explain why I multiplied 2 times 17? Because, okay, let me go back. See if I can get back to where I was.
Basically, aren't we just using a version of the distributive property?
Yes, when you sit and think about it from that perspective, that's true. I just find it rather interesting that you can do that. Keep losing my signal on my iPad. I just find it interesting that that thing turns out that way, and it can be just about any type of problem you want, knowing the difference between that next set up. And I can't get back into my screen mirroring. I'm sorry. It seems like I've lost my iPad connection. So yeah, it seems like I've lost that thing. It is a form of the distributed property, by doing it. And now once the kids get used to, I guess you guys can see the chat up there. Once they get used to seeing this, they find out that all you really have to do is realize that 1700 minus 2 is 98. And that's that number in the middle. But for this to work, it has to be a number times that difference plus that difference squared. It's really a real sweet little problem. I do like it. Will I ever use a 2-digit difference? That's an interesting question. Yes, I've been doing the single digits for a couple of years now, and I think it's about time to step it up to a 2-digit number. So yeah, I can see that happening, but I'll have to be careful. It'll have to be 2 digits that you know the squares. Otherwise, it gets too complex. It could be something like times 12 plus 144. But I wouldn't do times 47, because when you add, you'd have to know what 47 squared was. So I wouldn't do that on a NumberSense test. Might do it on a math test, but wouldn't do it on a NumberSense. Yeah, there'll be some 2 digits. Yeah.
I thought you'd go like maybe in the teens first, just to get it
Yeah.
going in the teens.
Yeah,
Nothing like that.
Yeah, it'd be the teens, and then somewhere down the line you might even get into the 20s. But I would never go into the past 35, because then you have to be able to do too many concepts at one time, and that might stretch the brain a little bit too far. But yeah, I think you'll see some double digits in the teens upcoming in the year. Others? I'll just move on unless somebody's got something they want to say. I'm just playing around with this test, this SAC test. Now here's another algebra trick, number 28. It's a lot like the difference of squares that we did with the squares earlier, but this was 4 above 30 and 4 below 30, which again is nothing more than 30 squared minus 4 squared. I'm sorry, not 4, 2 above 30 and 2, wait a minute, take it back. It's 8 above 40 and 8 below 40.
There you go.
Yeah. And so it's 40 squared minus 8 squared, which is 1564. No, if they recognize these kind of things, and the only way they'll recognize these things is they have to actually look at tests and ask questions. Is there a shortcut here? Is there a quick way to do this? And then once they figure it out, once they figure out what 32 times 48, how it really works, they write that on one of their cards as a remembrance. So the next time they see a similar problem, they go, oh yeah, I got a card on that. And they go back and they look at that card. So that's a really nice little problem as well, to look at the difference of squares from that perspective. See what else I have here.
How about number 33?
Who?
33.
33. Okay. If you look at that, that is a Fibonacci characteristic sequence. Now, you know, Fibonacci sequence is 1, 1, 2, 3, 5, 8. But a Fibonacci characteristic sequence is you take the first two digits, first two numbers, and you add them to get the third. 3 and 6 is 9, 6 and 9 is 15, 9 and 15 is 24, 15 and 24 is 39. And then 39 and 63 will give you n. See how it works?
Mm-hmm.
Yeah, that's a Fibonacci characteristic sequence. You would want to say Fibonacci starts with 1, 1, 2. It does. But this is a characteristic sequence in the sense that it takes two to get added together to get the next one. And they go on down the line. What about 27? Oh, I'm going to say 27 is not there. What about 27? Okay. Bases. I brought bases in pretty strong here, not a long while back. Wish I could get my dead burn. I'm still trying to get my thing to connect, and so I can show you that. I'm having troubles. I'm having troubles sharing that iPad for some reason. It doesn't seem like it wants to talk. Oh, there it is. It's trying to talk now. I don't know why it's having trouble, but it is. Okay. Okay, now I've got to think about what that problem was. What was that problem? What was the problem we wanted to look at? 27? Oh, 135 base 7. Okay, thank you. Okay. The Euclidean algorithm way back when, by the way, I'm doing a great study on Euclidean geometry through Hillsdale College. You get a chance, you ought to take that free course. It's fantastic. Anyway, there's a division algorithm that you can use to work problems like this. So how do you find this in base 10? Even though I don't put the 10 back there, I'll put it there for now. You realize that 5, oh, sorry about that. Somehow that 5 is in the ones place. That 3 is in the sevens place. And that 1 is in the 49's place. So we take those all right there and get 75. Yeah, 75. Ooh, terrible, terrible writing. 20, that can't even do that right. 75. You have to use the place values. And that comes from base 10. Base 10s has ones, 10s, hundreds. Base 7 has ones, sevens, 7 squares or 49s. Base 5, 1, 2, 4, base 5, that's 4 ones, 2 5s, and 1 5 squares or 25s or 5s or 1s, and you just multiply them out and add them together. That's base math. And if anything you can do in base 10, you can also do in any other base. Now, according to the chart, sequence chart, only thing I can do in sections 21 through 40 is to convert bases to base 10 or from base 10 to that base. I can't add them or subtract them or do any operations. I can just do conversion. And I don't think I've ever done a 4-digit conversion unless it's in base 2 or base 3. But that's how those particular things work. There's not any magic to it. You just have to know what your place values are as they go along. Now, I was going to tell you about the division algorithm. How do we go from base 10 to base 7? Well, you could figure out how many 49s are in there and so on, or you can use the division algorithm. If I take 134 and divide it by 7, watch my math, make sure I don't make a mistake. That remainder is there. Then I take the 19 and I divide by 7. That remainder is right there. Then I take 7 and divide it into 2 and I get 0. That remainder is right there. And so 134 in base 10 is equal to 251 in base 7. 251 is base 7. That's the division algorithm from Euclid. Euclidean division algorithm. That is really nice to do. I've had people ask me, how in the world can you convert over from base 10 to another base so quickly? It's really quick. It is really quick. You just hold your quotient and put down your remainders, and it goes pretty fast. I'll show you another one because I know you want to see one. 245 and take it to base 8. Now, if I divide 8 into 245, I get 30 with a remainder of 5. So it goes up there. And I take 30 and divide it by 8. I get 24 with the remainder of 6. And then, of course, the left things left is a 3. Goes pretty fast. It's pretty sweet little problem. Okay, questions? And let's go back and see if we can see some more things that I found. Oh, I was going to go look at number 48. Now, I want you to understand 48, just because it's way back in 48, that problem 23 squared plus 28 squared is just the sum of two squares, and that can appear early. Doesn't have to appear this late. I just don't put it early a lot of times. But there's something magical about that problem. If I can get my thing back. See if I can shrink this a little bit. There we go. Was it 23 squared plus 28 squared? Yeah. Now there's a magic behind this. Of course, you could, you know, your squares, 23 squared, 28 squared, you could do it and you can add, but there's something magical here that is going on. Does anybody know the magic in this particular problem? This problem is different from that problem. Does anybody know why? Anybody want to unmute and tell me? Okay, I'll tell you.
The second one, the 6 and the 4 are add up to 10,
Right.
and the others add up to 11.
Yes. But and that's how you have to teach your kids. What do you see? Now, as it turns out, what you saw doesn't help us any. So let's go back up here and look at this. Notice that the outside adds to 10. All right. Also notice that the insides differ by 1. Now, when that happens, the outsides total 10 and the difference determined by 1, this problem becomes very, very easy. It's 13, 13 without knowing the squares or whatever. And it comes about because anytime it's in this situation where the outsides total 10 and the insides differ by 1, I take that number right there and I square the 2, I square the 3, and I add them together and I get 13 and I repeat it. Isn't that sweet? And if you'll take 23 squared with your calculator and add 28 squared with the calculator, that's what you're going to get. And that will work every time as long as the outsides total 10 and the insides differ by 1. And that thing is just, that's a sweet little problem. To me, those are the type of problems that get kids tickled and get them wanting to know more. Then they'll see a problem like this one and they'll say, wait a minute, that doesn't work. Both back ones total 10, but there's no difference. No, that doesn't work. And then they're going to end up asking you a question. Well, what happens if I do this and I have what if they both outsides 10, insides 10? Will that work? I don't know. Maybe so. I'm sorry, I need my squares in there. I don't know. Maybe so. But they'll start getting inquisitive as when things will work and when things won't work. There's one that works with 24 squared plus 84 squared. There's a nice trick for that one, but it has to do with the fact that the fronts in it total 10 and the backs are the same numbers. These are the neat things about NumberSense that get to be really, really cool to see. So like I say, that I like doing that kind of particular problems. Well, I got questions running in. Oh yeah, somebody asked, Sam, depends where the president is. I believe, let me go see if I can find that for you, Sam. So you'll see it. I'm looking for my, maybe I can find it here. All right, Sam, if you go to the academic webpage and go to the conference, go to Capital Conference, you can go to this program.
He stepped away, Mr. White.
Pardon?
He stepped away. I think he answered the front door.
Oh, he stepped away?
Yes,
Oh, okay,
he's coming back.
okay. Is he back?
Yes, Sam's back.
Okay. All right, Sam. If you go to the academic and go to the conferences, go to Capital Conference, and there's a program there. And you can go that program and you can go all the way down to the bottom. Not all the way to the bottom, but very close to the bottom. You'll see these videos, these pre-recorded sessions. And that's the YouTube pre-recorded session I have. And then there's part, let's see if I can get to it. There's a place where you can go to get the downloads. Is there a quick link to the downloads, David?
It's on that, well, it is in the reminder email that they received. I don't think we have that in the program,
Yeah.
that
yeah.
link, but it is in that reminder email we sent out.
Yeah. Okay. So if you look at that reminder email, you'll see that. And I think David put it somewhere on here.
I'll post that in the chat again, that link.
Yeah, there it is right there. It's in the chat. It's right there on that. If you go to that chat page right there, you will find the presentation handouts. And they're down there at the bottom. You'll see my this information, and then the presentation is in that video presentation. If you want just the presentation, if you'll email me, I'll send you just the presentation without the video part of it. I can do that for you. That won't be a problem. Okay. I don't know. Do we have any more questions, or this time disappears so fast when we're having a good time? I could work NumberSense problems all day long, and I'm sure you could like to see a bunch of them all day long. I listed some fairly good resources for you to look at in the presentation. You can look at, so look at those resources, especially look at Brian Heath's deal. It's pretty good. Let's see if I can find it for you. Yep. Come on, Brian, where are you? Yes, it's brianheath.com NumberSense tricks manual. It's about 168 pages, full of all sorts of shortcuts and ideas and practice problems. You may want to take a real good look at that. It's got a great price. It's free. You can download it. So that's pretty good. For those of you that are beginning new I highly recommend Don Scow's No Sense in Mathematics. Don Scow was the NumberSense director before me. And Francis Walzel's little red book, The Mental Math, is a really good elementary, junior high, beginning book that you might want to look at. And of course, Leo has some stuff, and so does it, Andy and John. But you know, I don't get kickbacks from these people, but I recommend them because I've seen their stuff and they are beneficial to you. There are others out there. I'm not saying there's not. I'm just saying these are some fairly good things to get and go to. And if you're looking for extra tests, you know, you can get tests from UIL and TMSCA. I write 12 tests for Hexco. Linda Tarrant from Hexco, I write 12 tests a year. Been doing it since 2012, I believe. You can go there and get my tests. They're written in UIL format. They're just meeting tests again, as if I was doing UIL. So that's another place to get practice tests when you run out of tests from UIL and TMSCA. So that's a good place to go see those, to get those tests. Like I say, if you want to see this presentation without the video, just give me a holler and I'll be more than happy to send it to you. It's just a PDF problem. So be happy for you to take a look at it. Yes, sir. What's your email? Oh, that's a good point. I thought everybody knew my email. But that's not a problem. You can go to my UIL webpage and you'll see my email. And it's not here. Huh. How about that noise? There it is. That's my email. And that's the link to my UIL website that I talked to everybody about. And there's my email. Feel free to use it. Do not let your kids use it. I can't help them. So, but you're welcome to use that and email me and ask any question that you want. I'll help you out to the best of my knowledge. As long as it's not a new problem. If it's a new problem, I'm not going to tell you about it. I might guide you, but I'm not going to per se tell you exactly how to do it. I'll guide you along the way. Oh, can you still see what I'm sharing?
Mhm.
Pardon?
Yes.
Okay. I wanted to bring up question number 74. I've been doing several of these remainder problems, and they sometimes don't show up there. Sometimes they show up earlier. There's all sorts of different types of remainders, but I'm really tickled pink with this one. And I've had lots of people ask me about how to go about attacking this thing. I think the state meat problem, let me see if I can find it. I believe the state meat problem was something like, I can't find it. Can't find it. Anyway, there was something like 31 to the
11th power.
Pardon?
11th power.
Oh yeah, 31 to the 11th power. Yes. Divided by 11, I believe.
I think so.
Yeah, I think that's right. And somebody says, how in the world? Well, I'm going to give you a really big hint. There is a little theorem that will make this problem a snap. Now I'm going to repeat that. So for those of you attending the conference, you're going to get something that somebody else was not going to get. There is a little theorem that'll make this problem, remainder problem, a snap. You think about those words I just told you. and you'll find an answer to this problem. Okay, I believe it's getting close to quitting time. Unless you have more questions. If you have more questions, I'll answer them. If you don't, I wish we could be together, because what we would do after, when our session would be over at the Capitol Conference, we'd all go meet in another room and we'd work on more problems. I spend most of my time working problems at the Capitol Conference, but can't do that now. Email me if you have anything. Yes, Jimmy. Jimmy? Lost Jimmy. Okay. If there's nothing else, David, you have anything?
Nope, just thanks again, everyone, for coming. And we have additional sessions coming up later in the week. So check those out. Mathematics tomorrow afternoon at 2 o'clock with our new math director. And then we have a calculator session with Dr. Burrell Thursday morning at 10.
Good seeing all of you and talking with you. I hope everything goes well and we get back to school and everything gets going like it should be. I look forward to seeing you at the SAC events if possible as we go along. So y'all have a great day. Have a great summer. Keep doing your mental math. It's good for you.
I did have a question, but it wasn't related to NumberSense. It was just
Okay.
the Capitol Conference. Like, this is the first time that I heard about the Capitol Conference. I don't know how I got on the mailing list, but I got on there and I'm glad I did. But in past years, is this, when we do meet live, is it also free, or is it just free because we're doing Zoom? And where do we like sign up, or like for next year? I'm starting to plan for next year. How does it work?
We do normally, when we have the in-person event, we do charge for that. It's not an expensive. It's about I think a $75 registration fee, and then of course whatever your travel expense would be. But we've typically have hosted it the last pre-COVID, the last few years. We've hosted it at the AT&T Conference Center, which is on the UT Austin campus.
Okay.
And it's a day and a half conference with sessions covering all different academic contest areas. We typically open registration in the spring for early registration for that summer's conference. And so if we're back on our normal schedule, I would anticipate we do that again. But there would be a registration fee when we're back to an in-person event.
Oh, okay.
Yeah, it's great. You need to attend it. You need to go to the student activity conferences if you can, where we can do face-to-face talking with kids and stuff. But yeah, the Capitol Conference is really a neat thing to go to.
Where are the student activities this year?
We don't have that final yet. That's been a little bit of a challenge, just figuring out as our hosting sites are determining what they're going to be able to do as we're kind of getting back into more of a normal school year, we hope. I do anticipate we will not have a full 4. Normally in the past, of course, we've done 4 student activities conferences. More likely it'll be 2 this year as we try to kind of ramp back up and get we're going to have to kind of ease our way back in. But as soon as we finalize those hosting sites, we will post that information. We don't have those dates and sites finalized yet.
Okay.
And I'll post all that information on my UIL website that I showed you earlier. Anything like that, I'll post on there as well to make sure everybody knows where it's at.
I miss all the visiting we used to do there, Larry.
Yeah, visiting's always fun. And yeah, I miss that. I don't like talking to my machine. Yeah, I like talking to people and talking to kids. Yeah, I miss it. But we'll get it started again. We're not going to let this thing beat us.
That's true.
It hurt us, but we're not going to let it beat us. Okay, if that's all, then have a great summer. Good talking to y'all.
Thank you. Bye-bye.